we're learning to factor a sum or a difference of cubes. Now this is different than a difference of squares. A difference of squares will factor, but a sum of squares will not. Well, with cubes, both the sum and the difference will factor. So we're going to talk about the pattern, and then we're going to do some examples so you can see it work. So we have the sum and we have the difference. So we have cubes here. A is cubed, B is cubed. To factor it, it factors to a binomial times a trinomial. And with the sum, our signs go like this. If this is positive, this is positive, then our next sign is minus and our last sign is plus. So the signs when we're factoring a sum of cubes is plus, minus, plus. And the signs when we're factoring a difference of cubes is minus, plus, plus. Okay, so we have a mnemonic that helps us remember how the signs go. And that mnemonic is SOAP. And SOAP stands for same. So you'll notice in the binomial, whatever this sign is, this one is the same. So if it's addition, it's addition. If it's subtraction, it's subtraction. So the first sign is the same. The second sign is the opposite. So if this is plus, it's plus, minus. If this is minus, it's minus, plus. It's the opposite. And then the last sign is always positive. Okay, so that's our mnemonic that helps us to decide the pattern of the signs. Okay? Now, next thing we have to do is figure out what is being cubed. For a cube, I am just cubing A. For B cubed, I am just cubing B. And the reason we want to know is because here we put the cubed root of that first term. Let me change colors so this will stand out better. We do the cubed root of whatever the first term is. So the cubed root of A cubed is what is being cubed. It's just A. And then here we do the cubed root of that last term. So the cubed root of B cubed is just B. Okay, and then here, what we do is we square this first one. So if this is A, this is A squared. And then here, we do the product of the two. This is A and B, so AB goes here. And here we square the last one. So the last one was B, so here we put a B squared. Now, subtraction works the same way. So once we set up our signs, it's identical. And since I did A cubed and B cubed again, this is the cubed root, A. This is the cubed root of the last, B. This is where I square the first one, A squared. This is where I do the product of the two, AB. This is where I square the last one, B squared. This is our pattern every time when we have a sum or a difference of cubes. Now, I'm going to prove that this craziness actually works. And I do not want you to write this. Do not write. So why is it that this thing that looks so simple here factors to this big, ugly mess looking? It doesn't even look like it would. Okay, so how do we prove that we factored correctly? You can multiply back. So when we multiply this binomial through this trinomial, what we would do first is distribute the a all the way through. And when we do, we get a cubed minus a squared b plus ab squared. And then we would distribute the b all the way through. And when we do, we get positive a squared b minus ab squared plus b cubed. And then we cancel. We have opposites. We have opposites. And do you see what we're left with? What we started with. So even though it looks ugly and it looks bigger and it looks more complicated, it is the factored form of this sum of cubes. You don't have to prove that to me, but I wanted to prove it to you. Okay? All right. So what do we need to look for when we're doing these problems? First, we need to make sure we have perfect cubes, because those are the numbers we can take the cube root of. So we need to remind ourselves of what our perfect cubes are. What's 1 cubed? 1. What is 2 cubed? 8. And 3 cubed? 27. 4 cubed? A little bigger, close though. This one is 64. Okay? And then 5 cubed is 125. And 6 cubed is 216. And 7 cubed is 343. And 8 cubed is 512. And 9 cubed is 729. And 10 cubed is 1,000. Okay, so I would like you to write down the perfect cubes so that you can use that to reference when you're working on today's sheet. Now for your quiz next Friday, I won't put anything higher than 6 cubed on there. Okay, because that's a no calculator quiz. I won't have a perfect cube higher than 6. Steps. If you're kind of thinking through, what do I do? What order I do it in? This is what we do. So first of all, we have to recognize that we have either a sum or a difference of cubes. So when we check that off, this is what we do. We set up our signs. Okay, so let's practice. We've got a binomial followed by the trinomial. Let's use our mnemonic. This is subtraction. So it's same, opposite, always positive. Okay, so that was step 1. Set up your signs. Okay, step 2, determine what is being cubed. So what did I cube to get x cubed? X. What did I cube to get 216? 6. Okay, so what's being cubed is what always goes in here. That's the cubed root of these two. What is being cubed is the cubed root of the first and the last. And then we plug into that pattern that says square, and then product, and then square. Okay, so we square this first one, x squared. Product of the two, x times 6, 6x. Square the last one, 36. Now, when I'm doing the product of the two, I have to go back and think about what's being cubed here, not about what the signs are in here. Once I set my signs, they never change. So when I do the product, I'm really thinking of the product here, not the product where the signs are. Does that make sense? So once you set your signs, you're not going to change them. Okay, I want you to try number 2. You try number 2. Same steps. First, you got to make sure it's a sum or a difference of cubes. And you set up your signs, determine what's being cubed, plug it into the square product square pattern. Okay, so it's addition, so it's same, opposite, always positive. What's being cubed? Now this is an 8, so it's not just going to be n, it's going to be 2n. This is 125, so the cubed root of 125 is 5. So we need a 2n and a 5.
How did you get 2n?
Okay, so I looked at this first term, and I took the cubed root of it, or I thought about what do I cube to get 8n cubed.
Oh.
So I needed the 2, because that's where the 8 comes from, and I needed the n to get n cubed. Okay, now here is where I square the first one. So if I square 2n, I get 4n squared. We have to square both parts. Square the 2, square the n. Okay, then the next one is where we do the product of these two. 2n times 5 is 10n. And then we square the last one. 5 squared is 25. Okay, now these are larger exponents. So when we think about cubed root, we're really kind of taking these exponents to see if they divide by 3. Isn't that what a cubed root does to an exponent? Yeah. So if I'm trying to figure out what was being cubed, what's 9 divided by 3? 3. Does this work? If I raised x cubed to the 3rd power to a power, I multiply, don't I? So when I have a power higher than 3, I would divide it by 3 to figure out what's being cubed. Okay? Now what's being cubed here? What's being cubed to get to 216? 6. Now what is being cubed to get y to the 6th? Y. Took a second. Very good. Y squared. Okay, so now when I come down here and I set up my signs, I've got a good idea of what goes in here. All right, same, opposite, always positive. Okay, so we know what the cubed roots are. We just figured them out. So an x cubed goes here, and a 6y squared goes there. So we are kind of, in effect, dividing the exponents by 3. So now we square this first one. So what happens when I square x cubed? A power to a power we multiply. So this becomes x to the 6th. Power to a power you multiply. And then we do the product. So it's 6x cubed y squared. We go alphabetically this time, with our coefficient coming first. And then we square 6y squared. So when we square the 6, we get 36. And when I square y squared, I get y to what power? 4th. Excellent. So this here is the answer. All right, 2 more, and then we're all done. Wow! And there's all the answers. Forgot to erase them. Now you know it. Okay, now these two don't look like sums and differences of cubes yet. They will be along the way, though. So if we look at this first one, it's a trinomial. It's not a sum or difference of cubes right now, but we can still factor this. The leading coefficient is 1, so just like we did yesterday, we would ask ourselves, what do we multiply to get 27 that we add, negative 27, that we add to get 26? How about positive 27 and negative 1? Does that work? Okay, now, when we had x squared, an x and an x went here. When we had x to the 4th, an x squared and an x squared went here. When we have x to the 6th, what do you think goes here and here?
x4, x1.
X to the 3rd. So what you're going to notice is, whatever the degree of this middle is what those leading ones end up being. And it does work, because when I do x cubed times x cubed, if I were to distribute back, when you multiply like bases, you add the exponent. So it does result in an x to the 6th. All right, now, this is almost mean, because do you notice that this first factor is a sum of cubes? And do you notice that the second factor is a difference of cubes? So both of these factor further. So the first one is a sum, so I would set it up plus, minus plus. The second one is subtraction, so I would set it up minus, plus plus. Same, opposite, always positive. Same, opposite, always positive. Okay, and then what is being cubed to get x cubed? Or what is the cubed root of x cubed? You could ask yourself that question either way. Just x. And what do we cube to get 27? 3. So x goes here, 3 goes here. Then we square the first one. We do the product of the two, and we square the last one. Now we do the same process with this second difference of cubes. So we get an x and a 1. We square, product, square. And that is the complete factored form of the original trinomial. So on that one, both parts factored, because one was a sum of cubes and the other was a difference of cubes. Okay, the last one. This is 4 terms, and all we know to do when we have 4 terms is to try grouping. So we would pair the first 2 and pair the second 2. When we look at the first 2, is there a GCF? X. And what power? Very good. And when we factor out the x cubed, we're left with what? An x squared minus 1. And over here we already had an x squared minus 1, so we don't want it to change. So what do I factor out? A positive 1. So I pull out what they have in common, x squared minus 1, and then I group what's left, which is an x cubed plus 1. And both of these factors factor again. The first one is a difference of squares, and the second one is a sum of cubes. So the first one factors to x plus 1 times x minus 1. And the second one factors to same, opposite, always positive, and then root, cubed, square, product, square. So we could write it like that, or we could note that we have 2 of these. So another acceptable answer could be like this. Those are both acceptable answers, the last 2 lines. Okay, and that's it for today's lesson, and you have the rest of class to work on the back of last night's homework, which is where you'll find tonight's homework.